And our next speaker is Yana, who will be telling us about OAuth authentication.
Okay, so I'm audible? Okay. Okay, thank you. So I will be presenting our work on OAuth privacy, so in collaboration with my colleagues over at KU Leuven. So let me start by saying a little bit about what OAuth is. So we as users typically encounter it on the web as these buttons that allow us to log in instead of creating a whole new account on that website. So for instance, it looks like this. When we click on that button, there is a screen shown to the user which contains some data being requested from the user, and the user needs to authorize the use of this data. So this is, for instance, Facebook's OAuth implementation. When we compare with Google login on the same website, we already see that there is different data which is being requested. Here it's the name, email address, and language preferences, and there's also no way here to opt out of certain data. So these differences raise questions such as, what is the role of these identity providers in ensuring that users can log in a privacy-friendly way? So what kind of data do they make available for websites to request? And how does their consent screen look like? And on the other hand, how is this data being requested by websites in practice? To answer this question, we performed a large-scale measurement of the use of OAuth scopes. And while we see that some of these scopes might be used for a legitimate purpose, such as providing a specific function on the website, another part of this data might be excessive and might be used for some analytics or building a behavioral profile of the user. So are data minimization principles respected in general on websites that use OAuth? And are there any differences between identity providers? Is it sometimes privacy friendlier to log in with one identity provider than another? And how do all these different elements interplay in terms of ensuring a way for users to log in a privacy-friendly way? So these are the questions that we aim to answer with our research. And so OAuth basically consists of a number of interactions. So the first one being interaction with the user, where they need to grant their authorization. Then this authorization can be exchanged for an access token, and only with that access token will protected resources of the user be accessible to the application, or the website in our case. But in our study, we only focus on the first part, which is the interaction with the user. And what it looks like on a technical level is, so when the user clicks on a button, this screen is shown to them, which contains the name of the application, the data being requested from them, and some way to indicate their authorization. And underlyingly, a request is being sent to the authorization server of the identity provider, containing a number of parameters, among which the scope. So this scope is actually used to indicate which data will be requested from the user and will be shared with the website. So what we did was to develop a method to automatically detect OAuth buttons with support for almost 180 identity providers. And because we saw that these OAuth buttons are typically found on login pages, we used a multi-step approach where we first look for login pages, then look for OAuth buttons on these login pages, and finally we click on each candidate OAuth button in order to initiate the OAuth process and extract the scope parameter automatically. So we use this method to crawl 100K websites, and because some of these scopes are, well, most of these scopes are IDP specific, we labeled them into 7 different categories in order to be able to compare the scopes among different IDPs. And so the categories which we considered were, for instance, the minimal category, which is the least amount of information that can be shared via a certain IDP. And then permissions related to reading and writing IDP-specific content. And we also considered sensitive data, as is outlined in the definition of GDPR, so health data, religion data, and so on. So in terms of results, we found 6,211 websites using OAuth. So we found more than 10,000 OAuth buttons in our dataset for 33 different identity providers. When we look at the popularity, so in this table we show the 15 most common identity providers, and in terms of popularity we see that Facebook is at the top with 5.52% of prevalence, and Google follows. And then there's also Twitter and Apple, which also are quite prevalent. Now when we look at the number of different scopes that these IDPs make available, we also see some differences. For instance, Facebook only makes 16 different scopes available, while Google has almost 300 of them. This is because they make all kinds of API calls available via OAuth. And in the other highlighted column, we see the number of websites which request a non-minimal scope with this specific identity provider. And we already see a difference here because for Google, it's only 3%, while for Facebook, it is much higher, namely 8%. So this could be due to the use of certain SDKs or because of the fact that Google's documentation for scopes is not very straightforward for the average developer. When we look at Twitter, there are only 3 different scopes made available. However, all of them include quite a lot of information. So we defined the minimal scope as the one that shares the least possible amount of data with the IDP. And for Twitter, this is the most minimal one, and we see that it already contains a lot of data, such as the tweets, the profile information, settings, and accounts followed, muted, and blocked by the user. So this actually gives no incentive to developers to limit themselves to the most minimal scope, and this might be the reason why 75% of websites using Twitter request a non-minimal scope. If we look at Apple, they also have only 3 scopes. However, none of them are non-minimal, so all of them are minimal, and Apple is kind of a special case because not only are all the scopes minimal, but they also allow the user to hide their email address from the website that they're sharing it with. So for instance, a unique randomly generated email address will be shared with the website instead if the user wishes that. We also noted whether the scopes were customizable to the user. So here, for instance, on the right is Facebook's screen. We see that we can deselect each data point individually, while for Google, it's more of a take it or leave it choice. So for whenever there are API calls, the user needs to accept all of them. So we see that only 4 of the identity providers in our data set actually provide a choice to the user, and even among the ones that do, there are dark patterns included because for Facebook, you already need to perform an additional click, and you need to deselect each attribute individually as well. So next, we also noted that some of the identity providers included a verification process. So for instance, Facebook has an app review which requires developers to request to provide an explanation for each individual permission that they are requesting, and sometimes they also request even a screen recording of the different use cases. So this might have a benefit for privacy, but we see that only half of the IDPs on our dataset have this kind of verification process. And finally, we also noted whether the IDP had guidelines on the use of scopes, so whether they actively encourage developers to limit themselves when using scopes, and this is also the case for roughly half of the IDPs. So we found 6,200 websites using OAuth, and we find that on 18.53% of websites, so roughly 1/5 of websites, there is at least one non-minimal scope being requested. So while some of these scopes might be for a legitimate purpose, other ones might be excessive or unnecessary. So in order to get a deeper understanding of how websites request these OAuth scopes, we performed a series of experiments, and we'll highlight 2 of them in this presentation. So the first experiment that we did was to compare different single sign-on implementations on the same website. So we look at websites which include multiple OAuth buttons with different scope categories. And we find that 23% of websites with multiple IDPs have differing scope categories, which indicates that, so it's possible to log in with one IDP that requests certain data, but it's possible to log in with another one as well, which does not request this data, indicating that this data is redundant. However, not all scopes can be compared across different IDPs, which is why we zoom in on Google and Facebook's use of scopes, the 2 most prevalent identity providers. And in the following graph, we see in the middle the scopes that can be somewhat compared between the 2, so the birthday, the friends or contacts, the gender, and even there we see that Facebook is requesting in a lot more instances this non-minimal data. So this on one hand indicates that it is sometimes privacy friendlier to log in with Google than with Facebook, but also that because you can log in with Google without sharing your birthday, this data was never necessary in the first place. The second experiment that we did was to alter the OAuth scopes. So we consider whenever there was non-minimal scopes, we reduced them to being only one minimal scope, and then we sent this request and examined how the website would react, whether there were any signs of breakage. So we did this experiment manually on 100 websites, And on 65% of websites, nothing happened, and we were still able to log in without any issues. So only on 24% of websites was the information which we left out from the scope requested after logging in. But then again, on 8 out of those websites, we see that this information was never used. So here is an example, this website, High Five. So via Facebook, you need to share your email address, birthday, gender, and location. And if you consent to this, so you complete the login process, then you are confronted with this screen where you need to complete your profile. And we see that none of the data which we granted access to is actually pre-filled. So this data is either not used or it is used for something else. So the fact that only 11% of websites show some kind of error message or interrupt the login means that this data is actually not really necessary for the website to function correctly. So the key takeaways from our work. First of all, we see a lot of variation between the different identity providers. So in terms of the scopes that they make available, whether they provide choices to the user and whether they include manipulative designs in these choices. We also see that in terms of transparency, there is little to none because the website and the IDP do not communicate to the user what the consequences are of accepting this type of data. So no transparency. And we also see that while a verification process might have a positive impact on privacy, not all identity providers have implemented such a method. And we performed a crawl on 100K websites and report on the prevalence of OAuth. So we find that 7.23% of websites use OAuth, and we find that roughly 1 out of 5 websites with OAuth request non-minimal scopes. So some of these scopes will be used for a legitimate purpose, such as providing a function on the website, but our experiments show that in some cases these scopes are redundant and this data processing is excessive because there is an alternative method which requires less permissions to log in. So for instance, logging in via another IDP is possible, but sharing less data or creating an account instead of logging in via OAuth requires less permissions. And also the fact that we can alter the scopes and there is no effect on the login process in the majority of cases, and in some cases this data is not even used. So in our paper we provide also a series of recommendations for both websites and identity providers in order to improve privacy in OAuth and ensure that users can log in a privacy-friendly way. Thank you.
All right, we have one question on Zulip, if the next speaker could start getting set up. So the question is, did you consider creating a browser extension that would remove the scopes from the URL request to give users the choice back?
Yes, I think that we considered it. We didn't do it, but I think that it makes a lot of sense given the fact that only 11% of websites break. So it's a great option for a privacy-friendly tool. Yeah.
Okay.
Did you consider alerting these 18% of the websites that they are requiring non-minimum information, or like contacting Data Protection Commission and to tell them, hey, there are 18% of the websites here that are non-compliant?
Yeah, so we considered this. However, I think that it is very difficult to file a complaint is not difficult, but if you want to actually pursue them, like in a case, I think it's very hard because it's a case-by-case basis, and also you need to test all of the functionality of the website in order to know whether they are in the end using it for something else or not. So it's very hard to know without having access to their servers. Yeah. Yes, that's very possible. Yeah, that's possible. That something we can do in the future. Yeah.
All right. I guess I have a question before. We don't want to get too far ahead on things here. So following up on the idea that maybe users or developers don't know how to use OAuth, did you think about, I know there are tools like for, I think it's for Apple apps, for iPhone apps that will like help them with their privacy labels. So you think there could be tooling that would help developers like figure out what attributes they should be requesting?
So to have more transparency in terms
Sure.
of the attributes, you mean? Yeah,
Uh-huh.
absolutely, that makes sense. And also, in general, having more granular scopes, because as we saw for Twitter, the minimal one contains so much data, and then there's no incentive. So yeah, granularity and transparency would be the first things to address, I think, yeah.
Great. Thanks again, Yana.